more with visual limits, and we're going to do some ones where we're not actually looking at a graph, but infinite limits or limits at infinity are really just a review of horizontal asymptotes using different notation. So we'll start with this picture, this visual one. As I approach positive infinity, all that means is that I'm going to go this way on the x-axis. I'm going to let x become really big, and I'm going to see what happens to the graph. So x is becoming big, 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 big. Okay, here's my graph. What's happening to my graph? What's it approaching? Well, that arrow seems to be getting closer and closer to whatever this line is. That seems to be at -1. So as we approach infinity, we're just approaching -1. Negative infinity is going to be the same concept, but just the other way. So I go this way, and I see what happens to my graph. It seems like it is also approaching -1 that way. So the limit as x approaches negative infinity is -1, and this is just because there is a horizontal asymptote at y equals -1. So here's a couple examples. These are some nice rational functions where I need to figure out what's happening at infinity and negative infinity. So for this, I'm going to compare the degrees. I see this is degree 5, and this is also degree 5. And then there's some coefficients 5 and 8. Oh my gosh, come on. Better at circling here. Okay, and what we talked about when we reviewed horizontal asymptotes is at infinity, pretty much the rest of these terms are going to become so small in comparison to that first term that we can just cross them out at infinity and pretend they're not there. So then at infinity, all that's going to be left is these leading terms, and then that's going to leave us with an output of 5/8. Because there is an HA at y equals 5/8. And that's what's happening at infinity. At infinity, we approach the HA. Okay, here, I'm going to compare my degrees and see that it's a degree 2 over a degree 4. Smaller on top, right? Smaller degree on top implies HA at y equals 0. So that means as we approach negative infinity and positive infinity, we're just going to approach 0. Okay. So we're just reviewing horizontal asymptote rules, but with limit notation. So we're just going to do a little practice with visual now, and we're going to do both both infinite limits and non-infinite limits. So as we approach negative infinity, let's go to our graph. Okay, we're going to go this way because we're approaching negative infinity. Find the graph. What does it seem to be approaching? Well, this arrow seems to be leveling out, and where does it level out? It seems like at y equals -3. So we'll say that as we approach negative infinity, we're approaching -3. This gets a little bit tricky. As we approach infinity, this is just going up, 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 right? So it's not really approaching any particular number. For now, we're just going to say, yeah, that's as x approaches infinity, y is also approaching infinity. So we're just going to fill in infinity. All right, so then what about the limit as x approaches -4? So here's x equals -4. Here's -4. Okay, from the left and from the right, it seems like we're approaching the same thing, which is -6. Okay. What about f of -4? So this is tricky. It's asking what the output is. Where is the point? So as we approach -4, we're approaching this little hole here. But then up here, we actually have a point at -4, 6. So this is at -4, 6. So we're going to say that f of -4 is equal to +6. Okay, what about the limit as x approaches 2 from the right? Here's x equals 2. From the right, we're approaching -4. Okay, what about 2 from the left? Here's x equals 2. As we approach from the left, we're approaching +3. Okay, that's it. And now you have just a little bit more Desmos to finish up here.